Hello everybody, this is Mr. Bowman. So we're still looking at handout 1.9. We're on the last question, question 4. So a lot of preview of what we're looking at here, then we'll go down to our questions. So evolutionary biologist John Endler studied Trinidad's wild guppies in the 1970s. He was struck by the wide variation among guppies from different streams and even among guppies living in different parts of the same stream. He was curious about whether the pressures for mating and threat of predators influenced the frequency of the color variations found in different populations along the river. Endler photographed hundreds of guppies and carefully collected data about their size and color and the shape and placement of their spots. He began to see a relationship between the types of streams in which guppies lived and whether the fish were bright or drab. Guppies were collected from 3 different locations in a stream: a deep pool, a shallow pool, and a pool behind a natural dam. The guppies were classified into 4 color variants: brightest, bright, drab, or drabbest. So we have kind of a scale there. And all his data is down here. Okay, so we're going to use that data to answer a couple questions. So create a relative frequency table from the contingency table. Okay, so a couple ways you could do this. Let's see what would be the easiest way. Okay, so I think we're just going to go ahead and have to actually work this entire thing out. So remember, a relative frequency table just means we're going to take our table and divide everything by the total. So I'm going to get my percentages, or decimals as the case may be. Let's go with decimals. And just divide everything in a table by 664. So, all right, so let's see, we get 0.006, and I paused for a second to go ahead and calculate these so you didn't have to watch me do all of that. So 0.307, 0.003, 0.316. Obviously these are all pretty much rounded, so, but 0.017, 0.027, 0.148, 0.191. So once again, I'm just dividing everything by 664 to get these. So 25 over 664, 5 over 664, 111 divided by 664. So that's how I'm getting these decimals. It's a little tedious, but in some cases it is useful to have those relative ones, because that way you have less dividing to do. Sometimes it's just dividing by 1, because this is just going to be 1, right? 664 divided by 664, which is kind of the idea. So anyway, 0.212, 0.256, 0.014, 0.011, and 0.280, almost done. 0.316, 0.355, and 0.328. Okay, so I'm just took all the regular numbers, divided those by 664, because that was my total, and that gave me my relative one. So like this is 0.6% likely. This would be 2.7%, 14.8%. So all of those you can convert to percents if you're more comfortable with those. It doesn't really matter. Okay, what's the probability that a randomly selected guppy has the brightest color variant given that the guppy was found in a shallow pool? So keyword. So I'm only going to look at the shallow pool numbers here. I think I'm just going to use my original numbers as opposed to my relative frequencies for this one, but it doesn't actually matter. So the brightest color variant for the shallow pool was 204, divided by how many shallow pool people? Guppies. I guess they're not people. So I go ahead and just plug that into my calculator. 204 divided by 236. 86.44% probability. And which is more likely, randomly selecting a guppy from a deep pool or randomly selecting a guppy with the brightest color variant? All right, so this is from our entire table, so out of 664. So deep or brightest? Okay, don't write the wrong one. So how many total deep pool ones did we get? 210, and brightest was 210. So looking at these are both 210 divided by 664. So it appears that these are equally likely. is kind of weird, but that's what it says. Can you conclude from the data that a randomly selected drab or drabbest guppy is more likely to have come from a deep pool? Why or why not? So if we look at drab or drabbest here, we're going to look at our overall breakdown. So deep pool versus shallow pool versus pool behind a natural dam. And it says most likely, so we're looking for the highest one. So if I add these together, because it's at or, I'm looking at 195. Shallow does not look good. 5 and 9 is 14. And behind a natural dam is 118. So yeah, we could probably say it's most likely they came from a deep pool if they're drab or drabbest, because that has the highest frequency of the other ones. So yes, you could say that because of the highest number.